question number 56 we have, for the redox reaction, the correct option containing stoichiometric coefficients after balancing the reaction. So we will balance this reaction using the ion electron method. MnO4 negative is being converted into Mn2 plus. तो यहाँ पे आप देखो Mn की ऑक्सीडेशन स्टेट MnO4 माइनस में कितनी है, दैट इज +7, and in the product it is +2. तो यहाँ पे क्या हुआ, reduction, and the change of 5 electrons is being taking place. So here I will add 5 electrons. Now balance the charge here. So add 8H plus and now add water. So here it will be 4H2O. So this is my first equation. Now in the second one, C2O4 2 negative is being converted into carbon dioxide. तो C2O4 2 negative में कार्बन का ऑक्सीडेशन स्टेट क्या है, दैट इज +3, एंड CO2 में इट इज +4. तो यहाँ पे क्या हुआ, ऑक्सीडेशन, एंड नाउ बैलेंस द नंबर ऑफ कार्बन एटम. सो एक कार्बन के लिए 1 इलेक्ट्रॉन का चेंज एंड 2 कार्बन के लिए इट विल बी 2 इलेक्ट्रॉन्स का चेंज. सो हियर दिस विल बी माई सेकेंड इक्वेशन. सो नाउ मल्टीप्लाई द फर्स्ट इक्वेशन by 2 and multiply the second equation by 5. So the equation will become 2MnO4 negative plus 10 electron plus 16H plus giving 2Mn2 plus and 8 water molecule. And the second equation will become 5C2O4 2 negative giving 10 CO2 and 10 electron. Now add the two equations. So you will get the resultant balance equation, that is 2MnO4 negative plus 5C2O4 2 negative plus 16H plus 2Mn2 plus 10 CO2 and 8 water molecules. Fine. So now you have to find out the value of X, Z and B, where X is the coefficient for MnO4 negative, Z is the coefficient for H plus and B is the coefficient for CO2. So if I see this equation, तो यहाँ पे X की वैल्यू कितनी हो जाएगी, X is equal to 2 and Z is equal to 16 and B is equal to 10. So if I see in the options where X is equals to 2, we have been given Z equal to 5 and B equal to 8. तो ये क्या हो गया, incorrect option. So now C for X equal to 1. So अगर X की वैल्यू 1 हो जाए, it means MnO4 negative के coefficient 1 हो, and तो Z कितना हो जाएगा, 8 and B हो जाएगा 5. Because we are simply dividing the whole equation by 2. So this will be my answer if X equal to 1. So option number 1 will be the correct answer. So we have option number 1 the correct answer. So moving on to the next one, we have question number 57, which says that the aluminium can form AlF6 negative because of. So students, you must be knowing that the outermost electronic configuration of aluminium is 3s2, 3p1 and 3d0. Fine. So in this case, it is forming the aluminium F6 negative. Means it is forming the 6 sigma bonds with fluorine. So it means it is expanding its covalency. So when it is expanding its covalency, it is using the 3d orbitals. So it means due to the presence of 3d orbital in aluminium, it can expand its octet and expand its covalency. So option number 3 will be the correct answer. So moving on to the next one, we have question number 58. So which is related to the strength of the oxidizing agent and reducing agent. So we have 4 reactions with us involving W, X, Y and Z, and on arranging WXYZ in order of the increasing ability as reducing agent, the correct option obtained is. So first of all, see in the first equation where X plus Z plus is giving X positive and Z. So it means X is undergoing oxidation, so X is my reducing agent, and Z plus is going the reduction, so it is the oxidizing agent. So means X is able to reduce Z plus, so we can say that X is a better reducing agent than Z. I hope student this is clear to you. Now in the second equation we have Y plus X, which is giving no reaction. So here X is not able to reduce Y plus, so we can say that Y has a greater reducing ability than X. So Y will have greater reducing ability than X. So now in the third equation we have W plus Z positive giving W positive and Z. So here W will be the reducing agent and Z plus will be the oxidizing agent. So means here W is able to reduce Z plus, so we can say that W has a greater ability of reducing agent than Z. Now in the fourth one we have W positive plus Y giving no reaction. So it means here Y is not able to reduce W plus, so W is the stronger reducing agent than Y. So you can see here W is a stronger reducing agent than Z and as well as than Y. So यहाँ पे सबसे ज़्यादा reducing agent कौन हुआ? W. And then you can see here Y is a stronger reducing agent than X and X is a stronger reducing agent than Z. So W के बाद आएगा Y and then X or least will be Z. So this will be the correct order. So according to the options we have the option number 3 the correct answer. So moving on to the next one, now you have question number 59. So which is a reaction of borax, and we have to identify the B and C compounds. So all the reactions related to borax are very important because they are frequently coming in the examinations. So in the first case the borax is heated. So when borax is heated it will lose its 10 molecules of water and it will become Na2B4O7. अब अगर इसको हम further heat करते हैं, so it will form the sodium metaborate, that is NaBO2 plus boron anhydride, that is B2O3. पहले ये transparent liquid होता है and further it will solidify and form the borax bead, and the borax bead test is very important to identify the transition metals. So in this case this is B and this is C. So option number 1 will be the correct answer. So moving on to the next one, we have question number 60, which says that the correct order of solubility of carbonates of alkali metals. So we have lithium carbonate, sodium carbonate, potassium carbonate, rubidium carbonate and cesium carbonate. So what happens is that as we move down the group, hydration energy decreases due to the increase in size and lattice energy also decreases due to the increase in size. But what happens here, the decrease in lattice energy is more than the decrease in hydration energy. The decrease in lattice energy is more than decrease in hydration energy. So due to this, the solubility increases as we move down the group for the carbonates for alkali metals. So cesium carbonate will have the greater solubility and lithium carbonate will have the least solubility among the alkali metal carbonates. So we can say, so this will be our order for the alkali metals. So option number 2 will be the correct answer. So moving on to the next one.